Our vision for construction in 2050, an AI-driven project solution. The challenges facing the construction industry cover several different topics. First off, the productivity of on-site workers, project designers, and project commissioners should vastly improve by 2050. Repetition, exhaustion, quality control, and sluggish management all hamper productivity. By 2050, improvements in physical capabilities, management, coordination, and assembly methods are to be expected. Secondly, the cost of construction will continue to be a challenge in the construction industry. Resource scarcity, supply constraints, and transport costs may be exacerbated by 2050. Solutions to predict, mitigate, or eliminate these issues need to be executed by then. Thirdly, the environmental impacts of each project, from material waste to the overall carbon footprint of each project, continue to riddle the construction industry. With a net zero emissions goal by 2050, the construction industry needs to evolve and meet these standards across the board. Lastly, workplace health and safety needs continual improvement into the far future, as quality of life improvements, removal of both ergonomic and site environment risks, and a reduction in the injury and fatality rate of construction are demanded.
Our idea to solve these challenges is an AI-driven project solution which entails several key implementations. They include AI project and factory management, augmented reality or AR for design and operation, fully automated and specialized manufacturing cells for modular construction, self-diagnostics for all processes, new materials for construction purposes, and enhanced wireless system using Internet of Things greater than 5G communications and other technologies. We will break down the details for each of these concepts.
The core of our idea is AI management of the construction process from start to finish. In a 2050 setting, it acts as the backbone of all construction systems as a human enabler in every step of the construction process. This includes assisting in project designs done with building information modeling, assigning tasks to factories meant to create building modules, and self-assessing the status of manufacturing and project development processes.
AR will hold important roles in project design, machine operation, material transport, and module assembly. Human design work will be largely done in AR, where the building information model can be accessed. This work done in designing building will be managed by the AI system, which can also perform design corrections and extensive solution analysis. Operation of certain machines may also be done through augmented reality, paired with extensions of the worker's body. These extensions could be implemented as physical enhancement for the workers or as a remote control from either inside or outside of the factory. This allows for much higher productivity per person and alleviates many workplace health and safety challenges.
With the construction of building segments, each part of the factory will be fully automated and AI managed. Factories will be broken up into manufacturing cells, meant for the modular construction of standardized building segments. Each factory space will simplify the process of material transport since all materials can be brought to centralized unloading ports, assembled in the appropriate manufacturing cell, and transported from these factories as fully fledged building modules. Standardized building segments assembled in these manufacturing cells will more easily follow the building information model compared with traditional construction methods and stay up to code.
Machines in both the factory and the field will be capable of self-diagnostics, where the AI system can detect or determine the cause of technical issues and correct them. The AI system can also micromanage each step in manufacturing and construction processes. Corrections to design, manufacturing, or on-site processes can be done either automatically or with remote workers depending on the scale of adoption.
By 2050, there will need to be several changes to the building materials that we use to construct things, whether they be for structural enhancement, the use of recycled materials, or the ability for building materials to be recycled. This can result from advancement in materials research or the continued investment and practice of sustainable construction. These materials should also be capable of being put together off-site for modular construction.
As many of the AI systems will share information with each other and be highly interconnected, it will use the future generations of wireless systems, such as Internet of Things, greater than 5G communications, and cloud computing. With an extremely high volume of data transmission and storage, it allows for seamless real-time communication and detailed analysis of all processes in manufacturing and construction.
So, what are the barriers for adopting this overarching AI-based solution and its constituent ideas? Why would this take time to adopt? Firstly, and most importantly, the fixed costs of the hardware and technology required, even for hardware that currently exists to realize some of these ideas, are steep. Continuous investments need to be upheld in the long term for the non-instantaneous adoption of these ideas. Secondly, the specificity of components hampers the adoption of automated machinery, as manual labor is currently required to complete a wide set of building component permutations. Transitioning to a modular setup as the new standard for construction will be challenging from a design perspective. Thirdly, the supply chain would need to be reworked to adopt a nodal, factory-centered model rather than having materials delivered to each site. An AI-based supply chain management solution can help with this, but issues with new material destinations and prefabricated components would need to be worked out between the right parties. Fourthly, lack of agreement among stakeholders and institutions may slow the adoptions required to make modular construction solutions a reality, especially when it comes to job and resource allocation. Finally, integrating these components into existing manufacturing and construction frameworks is a time-consuming and management-intensive process. New skills and training would be required for all workers involved in the construction industry, and the willingness to adopt these solutions would need to be widespread and convincing.
The impact the solution would have on construction in 2050 is wide-ranging, solving or diminishing all previously mentioned challenges. Efficiency in construction speed would be greatly increased thanks to AI-assisted design, manufacturing, prefabrication, modularity, and on-site management. Workers' safety would be improved with the elimination of most physical risks. Decreased repetition, AR extensions, and factory-based fabrication would help relieve ergonomic and physical stress from workers. There would also be reduced site complications and weather conditions which affect the safety of workers, since time on site is reduced. With a factory-based solution, consistent quality can be assured amongst prefabricated building segments, given the precision and controlled conditions of a manufacturing solution, compared with the inconsistencies of an on-site assembly. Both greater energy efficiency and the reduction of waste materials are also expected with these implementations, allowing for environmentally sustainable construction.
That is all for our AI-based project solution. Let us look forward to 2050.